second speaker, Peter Houghton. He will talk about token swap and
Just give me a minute. Shaded Microsoft. Yes. Hi, I'm Pete Houghton. That's my company. You can see it very small around the investigating software. I'm a sort of self-employed consultant, and I help people and companies and banks, organisations, organise how they do testing using modern tools. So quality assurance, but not the traditional sort of outsourced sort of quality assurance you've probably seen before, how to use modern technology where it's available to help you. Okay, and I'm going to talk about how you can use AI coding tools, and therefore tokens, to help you improve the quality of your systems, and a little bit more. Okay, so my sort of conjecture that we're going to use is test automation has a solved problem. That will upset some people, but we'll go with it for now. But investigating your software isn't. Okay, quality is many things, and you can't just use a playwright script to check quality. There's much more to it than that, especially on large, complex systems. Okay. For example, using banks here, is your system double charging? It's easy to check automatically with a script written by a coding engineer that you are charging the correct fee for a payment. But is it double charging? Is it triple charging? Is it doing something else weird behind the scenes that you don't really know about? So those sort of side effect issues, they typically require some sort of investigation. Okay, so to help us think through the sort of problems that you have in large organisations and banks, you need to think in terms of rules, because banks run on rules. Banks run on thousands of rules. Payment systems run on rules, and the world runs on money and therefore payments. Okay, so have a think about this one. What's the opposite of a vampire? You don't have to shout it out, but have a think. What would make, for you, what's the opposite of a vampire?
a priest.
It's not a bad one. Okay, so let's think about the properties and rules of a vampire. So if you look at the canon of fiction, they're aristocrats, okay? They need to stay near their coffin because at night, you know, they have to go back to their coffin. They've got supreme self-control, right? They really know what they're about. They're not sort of lumbering around or anything. They've got control, and they can control others as well, okay? They can bend people to their will. And they have a thing about garlic for some reason, so they're not happy with that. Okay? Now, if you ask ChatGPT, it says the opposite of a vampire is a blood donor, okay, which I think is okay, right? If I had to come out with one, it's okay, but it's not brilliant, right? It's not maybe doing that extra thinking that you would want. Okay? The opposite, I would say, is a werewolf. Okay? Now, it takes a bit of thinking about, but if you think about it, right, so it's not an aristocrat, it's a vagabond, itinerant. It's roaming the country, roaming the woods, okay? It can't control its own emotions. It's like just constantly shouting, arguing, like, wants to bite people. It's just complete opposite of a vampire, okay? Just wants to bite people. It doesn't care about whether it's got a bit of garlic in it, it'll just bite it, eat it, it's happy, okay? So when we look at rules systems use, finding the opposite of those rules and applying them and using them to investigate what's going on is actually pretty helpful. It really gets you to think about how the system works. And that's when I encourage people to do testing and quality assurance for their systems. You think like that. You think in terms of what are you dealing with, break down the rules, and then examine those one by one, do the inverse, and like, is it doing this? Is it not doing that? Okay? And this is where AI agents can come in fairly useful. Okay? Why do we care again? Banks run on rules. So who's heard of SWIFT, the payment system? They keep trying to ban countries on it. SWIFT CPPR Plus is kind of the global payment system if you want to send money to someone on the other side of the world. Even if you're using like a cool trendy app, you're probably using SWIFT behind the scenes somewhere within that. Okay? Just the usage guide, not the rules, is over 1,000 pages long in a PDF stack, and a bank will typically have several of these payment schemes, okay, that they have to deal with, not just SWIFT. They also use XML, so they're up to the age of 2005 in terms of technology there. They also use XML, which is from the same era, and COBOL, as well, which is from the 60s, I think, or 50s. And they have more rules, not just payment rules, they have things like contractual rules, where they're dealing with big corporate partners, so they'll set up things differently for that. And they have things like BAM rules, so each individual account can have its own set of particular charging rules or other rules that they deal with customers, okay, and there can be hundreds of these. And typically, if you're testing a change, you might be dealing with 500 BAM rules alone, as well as, say, 300 for each scheme, as well as contractual stuff and working with the XSDs, okay? But luckily, coding agents can really help with this. So one thing you can do is take those rules and create a validator, and that'll be the first step you do, okay? So you don't say, oh, I just want you to build me a system to generate test payments or whatever. If you make the first step you do is create a validator, you can then use that validator and the coding agent say, give me one that fails this rule, give me one that fails this rule, give me one that fails this set of rules. Okay, and that's much more useful for testing a huge banking system with easily 100 separate systems touching your payment as it goes through. And each of those systems itself has probably got a dozen or more kind of systems in it. Okay, so it gets very complicated. Okay, so if we take a good example, it's simplified, banks still use it, but this is the sort of thing we take. The old NIST password complexity rules, okay, so I think you've got 6 or 7 rules there. The sort of thing where you have to guess a word that's got uppercase, lowercase, symbols, cases, whatever, okay? It's a real pain in the ass, okay? But what you can do is, if you take each of those rules and give it to a coding agent, like Claude Code or Copilot agent mode, it can give you a failing example for each of those rules. So that would help you test it quite easily. It can do that pretty much automatically, okay? And for those of you who are paying attention there, the last rule can only fail if 2 rules fail, because they're too short to have the different combinations, okay? So with a little bit of prompt engineering, you can make it provide comprehensive test data just from the rules that you already have, because you're a big organization, you write stuff down anyway. There's already a slide deck, a rule set, a spreadsheet, let's put all that in, okay? And you can use a similar method, okay? You can say, I don't know the rules, because you might be dealing with a legacy system that isn't well documented anymore, or all the people have moved on or passed away. You can say, find me the rules. And you'll do a reasonable job of that. It won't guess all the edge cases, but typically it's actually pretty good at varying. Once you give it a hint, here's one thing that fails a rule, you'll go off, vary inputs, and discover more rules, which you can then use to investigate the system further. And it's pretty good, especially Claude Code, is very good at finding errors in the rules. So depending on what format your rules are in, so the Swift ones I was talking about, they're actually in sort of pseudocode and prose English, so just plain English. It can find out if those rules, or a system that's coded those rules, doesn't actually work that well. If it's not really defined those rules well, it'll try and break the message, it'll vary, create the message again, and it'll actually try out, test out the validation, say, is the validation still working? Oh, it is, okay, so there's a problem with this rule. So that's pretty useful. Okay, so if we go a bit further into that payments example, like I said, there's hundreds of rules. Some of those rules, the usage rules, are the ones that aren't XSD, they're the ones in plain English, okay? They are quite useful, and they often allow companies to increase their straight-through processing. So when you send a payment around the world, the thing that stops your payment happening like that is because there's something wrong with your payment. One of the fields isn't quite right, okay? And that's typically in these usage rules. The other XSD rules, that's code level, that can be quite easily caught at the time of submission. But usage rules are much more subtle. So basically, if you have those rules, as we do here, we can then do clever stuff with them. Okay? Why this is useful? Banks currently still use COBOL. They still use things from the 80s, the 90s, before all of that and after all of that. And all these systems are connected together. Like I said, if you send a Swift payment through a major retail bank, one of the big 4 in the UK, it's probably touching 100 systems before it comes out the other end. And then it goes through other banks to a next system that probably also has 100. payments systems payments chain. Okay, it can take a long time to do all this testing and development. What you can do with coding agents, typically the quality assurance testing side is less constrained because no bank's going to let you YOLO a new payment engine into them because it's too critical. But you can go off and build a completely new way of testing something as long as you actually find information, bugs that they care about. Okay? So we can use coding tools to out-jump the rest of the process. So if we go back to those rules, we can reverse the process. Okay? Instead of saying the typical way about works is, oh, we're going to build a team, set up a project plan, get an environment, get a part of the building to work in. We can actually say, let's just start with the rules, especially on the QA side. Start with the rules, create that validator, build an application on top of that that allows us to test things, and then almost from there we can do a lot. So this is the example of what I did. So if you look at the top, that's a spreadsheet with these rules. There's typically 30 or 40 for each individual message. Okay, and then create the validator there. It's command line one. That works really well. I've actually found command line works better than MCP. It's much quicker than using it with a coding agent. And it's also easier than MCP to debug because you can go to the command line and actually see it like, oh, yeah, the validator's actually got a bug in it itself. Okay, MCP, obviously streaming, HTTP is much messier, it's hard to see what's going on. Maybe looking at logs and stuff like that. Okay, from that, you can then use the coding agent to say, okay, here's an example message, can I create this completely different version of the message on your own? And it will do that because it can check what it's doing against the validator and just go around until it actually gets a valid message. Okay, and these messages can range wildly. Okay, so you have many hundreds of different fields, all sorts of situations. So one of the classically weird ones is instead of sending money from one person to another person, you can include a government mandated garnish. So if that person that's receiving the payment or sending the payment has to donate a certain amount of money to a different organisation, that can be specified in the message itself. Right? If they have some sort of tax debt or something that is mandated for that person and the bank has to enforce that, that would be one of these edge case components of a rule. Okay? You can say, go create one of these, and the validator will be fine. It'll just say, oh, you haven't got that yet, you haven't got that yet. Oh, there's a bug in that, there's missing text, and it'll go over it. So from that, you can then say, okay, now, maybe I'm working in a restricted banking environment, now I'm a higher environment, I can't use an AI tool, but I can use an AI tool to use those rules and the messages I've created to create a non-AI application that can deploy anywhere and runs traditional test automation there. Here's just a spreadsheet I did where you then pass this into an app and it would take those fields that are specified there, create the messages, send it in on it goes. Okay, and then I create this nice funky web app here that also is an MCP server and it does validation for you. But this is the easy stuff. The hard part is the rules, right? The first step is get those rules that are written in spreadsheets, convert those into Python or whatever language. Then you can easily, with the coding agent, build a nice web app on top. That's the easy part. Okay? But, who guards the guards, right? How do you know that what you're building is actually good for testing stuff? Okay, so we can go back to the root source of all this information, where the rules. So you make sure you're constantly checking the rules. You can do spot checks. Does this particular message or rule report actually make sense? Swift itself has this really clunky, horrible manual validator, so you can put your messages in there. It's a bit buggy, so it's not the sort of thing you really want to automate against. You can cross-reference rule sets. You can say, 2025, compare those rules to 2026, because these rules change every year. Are there any anomalies between them? And things like Claude Code will quite happily find differences out, saying, actually, you've got way more rules here than you have in this year. This is a gap, this is where you're going wrong. It prompts the LLM to look that bit harder in specific areas. Okay? And you can just say, can you review these? Claude Code's actually good if you set up a new session and say, just go investigate this. I think there's some issue to do with a particular type of thing. We'll investigate it deeper, and that's useful as well. Okay, so one final bit. Reconciliations is a huge part of thanks as well. So you can use the same sort of approach there. In reconciliations, right? So you've got, the bank has hundreds of different ways of receiving messages about payments it's made or received and other information. It needs to connect those all together and say, oh, we got this thing from the trading office, we got this thing from the other bank, we got this thing from our own internal auditing department, we got this thing from over here. All these messages are generated by systems that span the last 60 years. Okay, they're all using different formats, XML, pipe delimited, tab delimited, binary formats, whatever. The reconciliation system ties all those together with rules and produces a standard output that then goes down on, they can actually invoice someone, and actually make money, for example. Okay? You can use a similar approach here with reasoning models or coding agents and say, okay, I've got this output, this is what we're trying to get, because if this figure in this column is above 10 million, then we need to invoice now because we're at risk of, not getting paid for that or whatever. Create the source data for those 12 different types of inputs that will generate that output. And it can iterate again over and over until it generates those files, which, having had to do that manually, and talk to other teams that do that manually, it's a real pain in the ass to do that. It takes forever, and it's not very reliable. Okay, so in summary, the steps you need to go through are, what is my test oracle? Okay, how do I know what I'm building is correct? So I said, look at those rules, okay, base everything on those rules. Don't try and throw all those rules into a coding agent and say, go build me some stuff. You say, rules, convert that into code, and then you can build on top of that quite reliably, because coding agents can then work with that. It's a set of functions, go build me a nice web app that sits on top. Okay? So the oracle is like the old oracle from ancient Greece. It's the source of truth, that's the source of what's going to happen. That's where you need to focus first. It's a slightly other way around to a lot of ways that development teams have worked in the past. Then build tools to help you investigate those rules and what you want to do with those rules. So I've got these rules, I want to check that my new bank system works okay. You can then investigate, like I said, using those tools in an application. And the more versatile those tools are, like command line tools and CP server, you can tie them in any way you want. And the good thing about all of this is you can bypass the huge bureaucracy that exists in organizations and say, yes, there's a 6-month, 2-year program to build a new payment gateway or whatever. I'm going to just take those rules, build a system that allows me to test what's coming. And I can build up mocks of the systems in between. In fact, better than mocks, I can actually build slow, small, miniature versions of what's actually going to come, and then test anything along that chain. Because usually the different parts don't arrive at the same time, and the mocks they do have are often not very good, right? So if you can build a simple system that does a reasonable job of doing their behavior, then you're pretty safe, basically. That's it. Sure, if anyone's got any questions on the exciting world of banking and levels, now's your chance. Feel free to connect on LinkedIn or read my exam log. Someone stretching or asking a question?
No, curious about how complex you would take this. So you could have some, I don't know about sort of banking and so on, but if you were, let's say, building a rule engine for modeling a business, you might have some very, very complex rules in terms of interaction between entities and then sort of utilization constraints and so on. So how would you handle all its statistical distributions as well? Seasonality, people can be only so old, and those sort of statistical constraints. So how advanced do you get with this?
Maybe not quite that advanced, but definitely some of the rules are fairly complex in the payment schemes, and they cross-reference as well between, basically a particular payment message, for example, is made up of multiple messages, and you have to correlate between those. But I think you probably could do it, but that initial analysis stage is where you're going to focus your work, and a certain amount of fusion goes up. And as I've found, as the models improve, you can go back and say, examine these rules, convert them, and newer models do better. Okay, some banking models are sometimes written in pseudocode, sometimes in prose English, and they've gradually got better and understand the pros and complete language code as well. So you probably take, if you had an example set, give it a go. It'd be reasonable. As long as it can be coded, right? I guess if you're talking about some things, maybe they don't reflect well in code. But these messages, because of anti-money laundering sort of rules, they encode a lot of information about people, and companies and locations, and things like that. So they're quite comprehensive, modelling the real world of business.
So how do messaging systems like Stripe, payment systems like Stripe, things like that, does it provide APIs?
Yes, I don't know. I deal with more core payment systems, so the bit that actually transfers the message that means the money gets moved. Banks don't actually move money, which is another big thing. They send messages about exchanging money between accounts they have within each other. I don't know how Stripe interfaces with that, to be honest. I assume, they have a partner bank that they work with, a real bank, deposit bank, and they just kind of refer on to them to use things like Swift and other systems. Oh no.
I'll ask another question for sponsors. You've also got me thinking a lot about, so we've been taking a big focus towards moving towards 100% test coverage across all of our client projects when working with LLMs. And we're experimenting with what that does in terms of over project delivery and regression minimization and that sort of thing. What you're inspiring here seems to be not just test coverage, which would be cool, you tested all the happy parts, but almost like 100% external coverage. And that seems like a really interesting, I don't know, I'm going to think about that for a while. But what's your thoughts?
Because the kind of positive test coverage, people and now LLMs can pretty much do that for you. You might worry about how detailed or abstract they were, what level, but they can do that for you. It's all the negative cases that currently they're not that great at, and people are still better at. And especially if you're dealing with systems, that's beyond the context of the documentation you're feeding in, let alone the elements. But people have that domain knowledge that can help.
Okay then.
Thanks, guys.
Thank you so much for your time.